Hey, welcome to the SATA and Google Cloud Ground School. Today I'm going to be covering storage on GCP. My name is Mike Craigen. I'm a customer cloud engineer here at Google. I'm based in Western Canada and deal primarily with public sector and higher education customers. Hopefully we'll be crossing paths someday soon and I can help you out with all your storage and more needs. So let's get into it. So at Google Cloud, we've got a number of different storage types depending on your use case, right? Everything from in-memory memory stores with MemStore, relational databases with Cloud SQL and Cloud Spanner, NoSQL databases, Filestore and Cloud Bigtable, as well as what I like to call our secret weapon in BigQuery. I'm sure you're going to hear a lot more about that later. But what I'm really going to focus on today here is the fundamental building blocks of object, block, and file storage. So that's cloud storage, persistent disk, and file store respectively. So object storage. So before we get started, let's review a few key terms in Google Cloud parlance, right? So an object is a piece of data and it's identified by an object name. A bucket is really a collection of those objects and they're identified by a bucket name, which is globally unique here at Google. The location is where the data is going to be stored, so that can be either regional or multi-regional. Something like US West 1 or potentially the whole European region would be a multi-region setup. And then the storage class. So these are how the different objects are going to be served up based on your use cases, access frequency, availability levels, and pricing profiles. So what is cloud storage? So this is Google Cloud's object storage offering. Right, it's a simple single API regardless of what flavor of this you choose. It's highly available with a 99.95 availability uptime and extremely durable with 11 nines of durability. So it's very cost effective. We can get costs down to portions of pennies per gigabyte per month, depending on where you're storing it and what flavor of this you have. And it's highly secure, just like everything we do at Google. This is encrypted not only at rest, but also in transit. So we've got different flavors of cloud storage depending on the use case that you have, right? So we start out with our standard. So this is either a regional or a multi-regional setup. It's good for things like video transcoding, storing images, websites where data is going to be frequently accessed and pulled. And then we move into, things that are accessed a little bit less, right? Less than once a month. So this could be things like backups. The flavor of this that we would use is nearline storage. Then as we move further into the depth here, cold line. So these things are less than once a quarter, right? So this is something like a movie archive or servers that rarely have access data. And then even longer term, we're talking archive, right? So this is really targeted at tape replacement. So again, the different storage classes that we cover here, depending on the needs that you have, right? And your access profile. So again, if it's something that's going to be accessed very frequently, we're going to look at the standard bucket. If it's going to be accessed, less frequently, like once a month or once a quarter, that's when we move further down the line to nearline, cold line, and archive. So again, regardless of what storage class you choose here, it's a single API for accessing all of this. So you don't have to learn a bunch of different APIs or profiles in order to know how to store your storage and move it around. Again, it's the single API, which is key. So after you've selected your storage class, we're going to move on to where this is going to be stored. So is this going to be regional data? So region is a specific geographic area, right? Again, we typically name these things like US West 1, US East 2. For Canada, right, we've got North America Northeast 1, which is our Montreal data center. Right, so that's a regional bucket. Multi-region is a large distributed area, right? So this would be something like Europe or Asia or the US. And then we also have a third class that's called dual region. So this is where we know specifically your data is going to be replicated across two regions. This is for lower latency requirements on some use cases. The cloud storage classes, right? So again, if we put all this together, we get a bit of a matrix here with your storage class on the left axis and the region on the right. And as you can see, there's different availability depending on, if you've stretched your data across multiple regions, or again, if you're just located in one area. And these come with different price impacts, as you can kind of see from the chart here. So I'll give you a minute to kind of look at that, and then it can help you wrap your head around the different use cases as we roll through this. Just to give you a bit of an illustration on how this data placement all works, right? So in a multi-regional setup, we're looking at the red boxes here, and they're going to be spread out across different regions, sort of as needed and as it sees fit for Google, and those regions can change as the data is stored, right? In a dual region, again, the blue boxes here, you're going to be across just two specific regions. You're going to have mirrored copies of your data in region B and region C in this example. And then again, for the lowest availability but quickest latency, right, you're going to have a regional model where in the yellow boxes in this case, where all of your data is going to be stored in a specific region, region B. So just to dive in a little bit more on these use cases, right? So a multi-regional is really the best for content serving, right? So something that's going to be spread across, North America, let's say, and you're going to have people accessing the data, sort of all over the North American region, right? We may pick the U.S. multi-regional setup, right? It's got simple pricing, a simple API, and it really offers the highest business continuity available because your region, you're now protected against a single or even multiple region failures because your data is going to be highly available and spread across the multiple different storage regions within Google's network. Again, regional, this really gives you the best for sort of data analytics because the region that you're going to pick, ideally you're going to co-locate your workloads in that same region. So you're going to have fast access to the data. You're going to be able to go from your workload to the data that you need very quickly on Google's backbone. Usually in low millisecond or sub-millisecond times in some cases. And again, it's ideal for running sort of analytic use cases, and it's really available in every region across the globe. Something we see often, things like genomics analytics, IoT use cases, machine learning typically use this type of data. Now moving into the different storage classes, right? So first of the less frequently accessed storage classes here is the nearline, right? So this is best for infrequently accessed data. Again, same storage API across the board, across all different storage classes. Again, this is going to be used for serving your long tail data, right? Stuff that you may access once a month, and things like backup, or you need to have this for historical recall purposes. And code line data, this is storage that you're actually using. Again, there's no spin up time associated with having code line, right? There's instant access to speed. There's no warming or anything of that nature. So again, archives, multimedia storage devices are really great for this use case. Moving into our last asset class is really the archive. So this is again really targeted for the tape replacement. We're really trying to get everyone off of those tape libraries that have been sitting in premises and buried deep in data centers, right? It's offered at a super low cost, affordable price. Again, this is for long-term data retention and probably stuff, to be honest, that you're never going to touch again unless a compliance reason or something comes up that you really have to access this data. We also offer tiering, right? So now that you've got, you can build tiering policies. So as your data is less and less frequently accessed, you may start out with a standard as the data is hot and people are getting in there and they need to access it frequently. But after 30 days, let's say if nobody's touched it, right, we can move it down into a nearline storage class in order to save you cost. And then again, code line and archive just based on a policy, and we can kind of move that down and start to automatically save costs for you and avoid you having to go in and manually reclassify data. And again, like everything we do at Google, it is 100% encrypted, both at rest and in transit. And we give you some flexibility on how you do that, right? So default out of the box, we do key rotation, we apply the keys for you, kind of hands-off management. If you want to get more involved in this, right, you can get the customer yourself can start to manage your own keys using something like the Google Cloud KMS, the key management server. So that gives you some more control and responsibility over rotating your own keys. And then even again, if for those customers that need to take it to that next level and really take control of their keys, right, we do support sort of storing your keys out of the cloud, and you've got full control over the keys. So any sort of highly sensitive data or regulated workloads, this is a great fit for that. Again, here's another chart for us to kind of have a look at. So again, this is depending on what you're going to do, right? So again, there's a consistent API all across here. Our availability SLA is moves from 4 nines with the standard down to 99.95 with archive. Again, that's availability. We still have 11 nines of durability across the board. Essentially, that means that if you ever put anything in here, you're basically guaranteed to not lose it. The way that this is all structured is for the standard line and so standard storage class, your storage prices are in per gigabyte per month, and it's a little bit higher but the retrieval cost is included and a lot lower, right? So as you move down the line and the tail of your data gets lower and lower, as we move towards the archive class, the storage price itself decreases significantly. However, there is quite a cost to access the data on a per gigabyte basis, right? So again, this is really meant for long-term archives that is going to be very infrequently accessed. All right, well, that rounds out that section. So let's move on to block storage. So block storage, our flavor of block storage is what we call persistent disk. So persistent disk is a durable and high performance block storage for the Google Cloud Platform. Primarily we see this used with Google Compute Engine and Google Kubernetes Engine. The persistent disk is provided in a few different flavors, right? Some backed by solid state drives, some by spinning disk or hard disk. And again, we typically see these deployed with GCE and GKE. The storage volumes they can be transparently resized, so you can scale up to 257 terabytes for a single VM now, which is quite a big disk. We offer quick backup and snapshot technology in order to allow you to back up and save your data. Again, the single disk max VM performance, right? So there's no need for you to stripe this and do your own RAID across the board. We handle that all for you. Right, so to step back and sort of look at the different flavors that we offer here, right? So starting on the left-hand side and moving to the right is the lower cost options, moving into the more performant options, right? So the standard PD, or for persistent disk here, we offer that for those cost-sensitive workloads, something that you don't need top-tier performance for, and perhaps bulk data here. Again, as we move into the balanced and the performance, these are become backed by SSDs, right? So these are more useful for things like enterprise applications, line of business, boot disks, and again, the price and the performance sort of match that. As we move up into our extreme tier, right? Like this was designed, and it's a relatively new release from Google Cloud with uncompromising performance in mind, right? So things like in-memory databases like SAP HANA. So this is a very high performant persistent disk. As we move into sort of the last layer, the local SSD, right? So this local SSD is actually going to be living on the same host that your virtual machine or your Kubernetes cluster is living on. So you're going to have very, very low latency. The challenge with this type of use case is it is intended to be ephemeral. So this isn't going to last long term. This doesn't support multiple different VMs attaching to it. This is for that single sort of focused use case of a scratch media or something of that nature. So some of the features of the persistent disk, it's a multi-reader support. So you can connect multiple VMs to a single persistent disk. For things like shared clusters, or if you do have just a driving need to have the data stored or stretched across multiple VMs, persistent disk is a great way to do this, right? It's fast and space efficient. We can take, as I mentioned, we can take snapshots. Those can be replicated in order to allow you to have the availability that you need to create your uptime. We can scale without interruption, right? So you've got the ability to resize your storage while it's still in use, while it's still attached to a disk, right? So if you're running out of storage, you've got the ability to kind of hot add storage. Again, as I mentioned previously, automatically encrypted, just like everything we do here, encrypted both at rest and in transit. So here's stepping back. Here's a persistent disk architecture. This is what it looks like from a simplified view. Right, so we do AES 256 encryption on all the in-flight and at-rest data. Right, as we attach to the different persistent volumes, you've got the resiliency and integrity built in. So multiple copies of all the data are stretched across our physical footprint of the back end. So even though we're just attaching a single persistent disk volume to a VM in this example, you can see that this is actually striped across several disks in the back end. So we take care of all the resiliency and data integrity for you. The performance characteristics, random write operations and are highly available, and they're read from the fastest copy, right? So whatever data that we get back first, we'll use that to present it to your VMs. So just a bit of a background of what we strive to do here at Google, right, is really these 5 key tenets of durability, security, high availability, consistency of performance, and speed, right? We want to keep those all as high and as consistent as possible. But again, the technology, it all still depends on how you use it. Hence we have some best practices that I'm going to step through here next for you. Right, so there's no need to create multiple disks and have these span across or spin up multiple disks and see which one's the fastest. Again, we're aiming for that consistency across the board. So regardless of where your data is going to land, you can rest assured that you're going to see similar characteristics across the board. Again, there's no need to warm up a disk before using it. These are all ready to go with consistent latency and bandwidth experiences across the board. So RAID striping, again, there's no need to use RAID or striping, right, to stretch this across multiple disks inside of something like a virtual machine OS. In order to do this, we handle that all for you. So the recommendation here is you actually use a lot bigger volume rather than having multiple disks. Your I/O will scale with the size of the disk. So again, using large I/O size for throughput. And high IOPS, right? So for high IOP workloads, larger queue depth helps performance, and it really lowers down lowers the block size, right? So one thing you really want to avoid doing is having IO misalignment, right? Again, so behind the scenes here, we've got 4K boundaries. So our recommendation is that you build all your block storage to those 4K boundaries. Any misalignment where you're stretching across a 4K block is going to have an impact on your write speeds. Again, for disk partitioning, we suggest using a separate persistent disk volumes instead of partitioning that disk, because as you can see from the example here on the screen, if you were to take one persistent disk and partition that, no longer are you now aligned to our 4K boundaries, so you're going to be stretching across those and you're going to take a performance hit in that. So rather than partitioning one disk into 2, as shown here, the recommendation would be to actually spin up 2 different persistent disk volumes and then attach those independently. All right, so moving finally here into file storage. So what is Filestore? That's our flavor of file storage here. So if you've ever, open, read, written, closed your code, you're using file storage in the back end, right? So file stores are, the same as what you would see from a NAS or network attached storage on premise. This is used with Compute Engine and Kubernetes engines or GKE instances. Right, so file storage architectures and some of the different APIs that we offer here, right? So these file systems are formatted on the block device, and we've got many different ways that you can attach here, right? So again, maybe you're attaching one to a specific VM, potentially a shared file system where you're using NFS or SMB to transfer data from multiple VMs to a single server. We've got a scale out architecture as well, where you want to stretch this across a cluster of shared data sets. And again, potentially a parallel system for things like high performance compute, where you need a lot of throughput into these files. All right, so here at Google, we love working with partners, right? So we've got a number of partners in the storage space as well that help with a variety of different use cases, from HPC and HTC data, backup and recovery, scaling cache, right? And then even running Anthos on premise or in Google Cloud. We've got a number of different partners here, all with their different strong suits. The session, unfortunately, isn't long enough to go into all of our different partner offerings. So I do urge you to go to the Google Cloud Marketplace and you can check out all of these different offerings that are available and what our partners bring to the table. Focusing back here on some of the file store use cases that we see most prevalently, a lot of rendering. So if you're in the business of creating content or rendering any sort of content, like this is a very good use case there. Application migrations, web content management, so again, serving out website data, media processing, so again, graphic design, video imaging, things of that nature, or sometimes just home directories, right? Everyone's got employees who want to access, that home directory. The Filestore is a great use case for that. Also, we're happy to announce the beta availability of Filestore High Scale. So this comes from our ElastiScale acquisition, right? So this is a fully managed scale-out solution. It supports NFS v3. Again, fully managed. You can scale not only up but also down. So as let's say you've got data that comes in waves, you have the ability to actually shrink back down your file store after you've grown it, which is fantastic. And this is great for cloud-native workloads as well. Kubernetes has native integrations into this. So just to step through some of the characteristics of Filestore, right? So again, there's two different flavors. We've got the basic flavor and the high scale flavor. Within basic, we offer both hard drive spinning disk as well as solid state drives. As we move up to the high scale tier, this is offered only with solid state drives. And the way that we scale these two are slightly different, right? So in a basic configuration, this is a scale up architecture. So you're increasing the size of the disk and the performance that way. Whereas with the high scale, this is a scale out architecture, right? And this is going to grow linearly with the size of the LUNs that we have out there. So again, there's some performance statistics on here around IOPS, right? So the basic tier at 60 terabytes, you're going to see 60,000 IOPS. High scale, you're going to see 90,000. And then, as you scale out high scale, right, we get up towards 500,000 IOPS. Again, you've got the ability to grow and shrink with high scale, but with the basic, again, it's just a growth. And you can see the price there. Again, that's kind of vary per region, but that gives you an idea of the costing. All right, so file transfer. So, we've talked a lot about the different storage options and some of the base building blocks here. In Google, that's just the start. So once we've got your data and we really want to help you do amazing things with it, whether it's just optimizing your infrastructure costs, building new experiences for your consumers, really connecting different business platforms, making your teams more productive. Again, whatever the use case is of your data, we can really help you enhance that and really transform your business. But the only challenge is, amazing things will only happen if you can get the data here, right? So again, there's lots of different challenges. Sometimes there's just massive amounts of data. Maybe your bandwidth upload to Google Cloud is not ideal. Checksumming, encryption features, and firewalls can also often cause a problem when you're doing massive data uploads, right? So there's a myriad of different challenges when getting your data here. To overcome these, we offer you a number of different transfer options, right? So there's a basic online transfer where you're basically just uploading everything into the cloud storage or the file store, the block storage that we've discussed here. We've got a cloud transfer service as well. So this is for larger bulk migration. This is for either Google Cloud region to region or other cloud storage platforms into Google Cloud. We've got a number of partners that can assist with this as well. Also, if you do have massive amounts of data and you're looking to bring it to the cloud and it just doesn't seem feasible to transfer it over the wire, we do have a storage appliance that we can ship to you. You rack in your data center. You'll upload the data that you need there, encrypt it with keys, ship it over to us. We'll rehydrate that data and put it into your projects as needed. And we also offer for enterprise data warehouses at large scale. BigQuery transfer service as well. As you can see, many of these, we'd urge you to engage with our partners, such as SATA, in order to help with this. So just a quick overview of what the transfer appliance looks like. I briefly touched on it. We'll ship you a box, a Google Transfer Appliance. You rack and stack that. You put some encryption on it. You either give it to FedEx or your preferred carrier of choice. We'll bring it into our data center, stage it in there. You provide the keys. We do the rehydration and put that into your, in this case, the Google Cloud Storage bucket, and you're off to the races with all your data now up in the cloud. So, and with that, I want to say thank you. I look forward to engaging with some of you throughout this day here.